Okay, section 4, solve triangles using the law of cosines. And so there are two cases that we're going to use the law of cosines to solve oblique triangles. The first one is the side angle side case, where we know two sides and an angle between the two sides are given. We'll use the law of cosines to solve that case. And then we will also use the law of cosines to solve the side case, where we know the lengths of all three sides that are given. So what is the law of cosines? Well, if capital A, B, and C are measures of angles of any triangle, and lowercase a, b, and c are the lengths of the sides opposite the corresponding angles, then we have the following. Two versions of the law of cosines, just like we had two versions of the law of sines. So the 3 on the left-hand side, a squared equals b squared plus c squared minus 2bc cosine a, b squared equals a squared plus c squared minus 2ac cosine b, and c squared equals a squared plus b squared minus 2ab cosine c. These three we use to find the length of the sides that's missing. If we need to find an angle first, then we use one of these three formulas on the right-hand side. Cosine A is b squared plus c squared minus a squared over 2bc. Cosine B is a squared plus c squared minus b squared over 2ac. And the cosine of angle C is a squared plus b squared minus c squared over 2ab. And again, these ones we use to find angles. These ones we use to find length of sides. And so just like law of sines, there's two different versions. And so it just depends on what we have to find first as to which one we use. So here is a side angle side example. We're going to solve this triangle. We know length of side B is 5 and length of side C is 11. And we know angle A is 48 degrees. So that is side angle side case. And so the things that we need to find are side A, angle B, and angle C. And so the first thing we're going to do is we're going to find side A. So A squared is equal to B squared plus C squared minus 2BC times the cosine of A. So that's 5 squared plus 11 squared minus 2 times 5 times 11 times the cosine of 48 degrees. And so when I plug that into my calculator, 5 squared plus 11 squared minus 2 times 5 times 11 times the cosine of 48 degrees equals 72.39563. And so side A is equal to the square root of 72.39563. So side A is equal to square root of 72.39563 equals 8.508. So 8.5 is the length of side A. And so now that I know side A and angle A, I can use that and the law of sines to find angle B, because sine of B over B is equal to the sine of A over A. So that means that the sine of B is equal to B times the sine of A over A. So the sine of B is going to be 5 times the sine of 48 degrees divided by the length of side A, which is 8.5. And so 5 times the sine of 48 times the sine of 48 is equal to that. And then we divide that by 8.5, and we get that the sine of angle B is 0.437. So that means that angle B is going to be the inverse sine of 0.437. And so when I do second sine on my calculator of 0.437 and round to one decimal place, angle B is 25.9 degrees. And so now that I've got angle B, angle C is easy. I just have to add A and B together and subtract from 180 to get angle C. So angle C is equal to 180 degrees minus the sum of A and B. So that's 180 degrees minus 48 degrees for A, and then 25.9 degrees for B. So angle C is 180 degrees minus 73.9. So angle C is 106.1 degrees. And so we have solved that triangle. Side A was 8.5, side B was 5, side C was 11, angle A was 48 degrees, angle B was 25.9 degrees, and angle C was 106.1 degrees. So that's how we solve a side angle side triangle. Now, with these side angle side and side sides, there's only going to be one triangle, so this is good. So we can solve using the law of cosines, and then the second thing we find, we can either use law of cosines again, or we can use the law of sines. It really doesn't make a difference when we're finding that second angle. But when we have all three sides, like in this case, to find angle A, I'm going to use the law of cosines. It says the cosine of A is equal to B squared plus C squared minus A squared over 2BC. So that's going to be 8 squared plus 12 squared minus 5 squared over 2 times 8 times 12. And so cosine of A is going to be, when I plug that into my calculator, 64 plus 144 minus 25 is 183 over 2 times 8 times 12, 192. So cosine of A is 183 over 192, so that means that angle A is equal to the inverse cosine of 183 over 192. So second cosine. 183 over 192. Hit enter, and I get angle A rounded to 1 decimal place is 17.6 degrees. Now, if I want to solve angle B, I can use the law of sines or I can use the law of cosines. But since this is a law of cosines section, we'll just go ahead and use the law of cosines again for this second angle. So if I'm going to look for angle B, then the cosine of B is A squared plus C squared minus B squared over 2AC. So this time it's going to be 5 squared plus 12 squared minus 8 squared over 2 times 5 times 12. So that's going to be 5 squared is 25, 12 squared is 144, minus 64 is going to be 105 over 120. So that's what cosine B is equal to. So therefore, angle B is going to be equal to the inverse cosine of whatever 105 over 120 is. So again, inverse cosine is second cosine. And then I type in 105 divided by 120 inside the parentheses. I close the parentheses, I hit enter, and I get that angle B is 28.955, which rounds to 29.0. And now that I've got angle A and angle B, angle C is just 180 degrees minus the sum of A and B. So that's 180 degrees minus angle A was 17.6, angle B is 29. So that's 180 minus 46.6. So angle C is 133.4 degrees. And so now we know all three sides, we know all three angles, we've solved that triangle.